In today's video, we're going to be talking all about performance engineering and what it takes to make websites perform both on the front end and the back end. I've been a performance engineer for over 25 years, and I've seen a sort of a divide happen within the engineering camp. We have people who are focused on specifically the browser performance and Google Core Web Vital metrics, but we also have a group of performance engineers who focus on the back end infrastructure, load testing, databases, and things like that. We'll find out what it takes to make these groups work together for a synergistic web application that just screams. So, if you're new to performance engineering and maybe you have heard or focused on one or the other, I want you to listen to this video all the way through so you can find out how we need each other, front end and back end. If you've been a performance engineer for a very long time and you've been using some of those load testing tools, but you really haven't focused on the front end metrics, you need to be doing that as well. And we'll talk about how to do that in this video. Who am I? I'm Scott Moore, and I've been a performance engineer for over 25 years. I've had my own businesses, and I've worked for several companies, consulted for many of the Fortune 500s to make their applications as efficient as possible. And I'm going to share that knowledge with you today. I've seen patterns like companies who do not focus on the front end, they focus on making a well performing engine on the back end, but they never actually check what the user experience is on the web browser itself. And they get bad reviews, or they have customers who move to another platform because it's very easy to do so in some cases. Then we have a group who really focuses on the browser itself, and they look at synthetic monitoring and real user monitoring, but they never pay attention to the fact that the cloud, although we think it has unlimited resources, it really doesn't. Resources can get constrained, and when it does, it will affect the front end and the user experience as well. So we really need both. So we're going to start with a little bit of a history lesson, and then we'll go into what it takes to make web applications perform on both front end and back end. Let's talk a little bit about the evolution that I have seen of web performance and architecture. When I started, we were in the early 90s, and we were seeing companies, especially large companies, moving away from the mainframe into client server systems. And in those days, we only had a database and an application server. We had one job: make the database server efficient. And most of the time, we didn't really have a problem with the application server. It was just a thick client that was sitting on the user's desktop. And in enterprise, that was controlled by some central resource that rolled out new versions of the software either over a period of time or it was automated. But it was pretty simple to see if you had bad SQL queries, or you were doing select asterisks or something, missed indexes. Those were pretty easy to fix. And then along comes the web, where the client became the browser. And then you had a web server that was sometimes combined with an application server and, of course, a database server on the back end. And these are applications that you work with all the time. Think of anytime you've went on a shopping cart or Amazon or whatever. It's basically that. It's a web server receiving your request from your browser, which your browser is the client. You can choose different browser types. You may be on different network speeds. There's a last mile that happens between your machine and what the infrastructure on the back end that receives it. So we have a group of people who have still focused on that back end piece. Can I make the web server fast? Can I make the application code fast? Can I make sure the database is fast? Can we make sure the network is fast? There's all of those components. And then there comes this piece of, well, what about the browser? And that's when we get to around 2007-ish. So you see there, when we get to between 2007 and today, we have this Steve Souders effect. If you're not familiar with Steve Souders, he wrote a book, a pretty famous book, about how to make high-performing websites. He worked for Google and several other companies. And he basically showed in his book that 80 to 90% of the load is on the front-end browser at the client side. And of course, this really kicked off a whole new generation of people who thought, well, we should focus on that front end as much as we're focused on the back end. But it becomes one of those things where I've sort of seen this natural divide where it's like, well, we can't know everything about everything, or we have to know where to divide our time. So just focusing on the browser is really a full-time job. There's all of these components that make up a web page, and we sort of kind of had to figure that part out. Whereas in the past, we were really just focused on the back end, or at least the group of people that I was kind of raised up with, that's what we were focused on. So we never really paid attention to the web browser as much because there were other people who did that. And somebody who understands both really, really well, sort of a unicorn in today's industry. There's just a lot to know. And if you're one of those people, great, you've succeeded. I wish that I knew everything about both sides myself. I'm always learning. So hopefully you are too. So let's dive into these two camps that I'm talking about. So on one side, you have your back end performance engineers who traditionally have used things like load testing tools like LoadRunner, JMeter, NeoLoad, and others to ramp up load of synthetic users. They would basically be threads of a CPU. They automate business processes and get timings, transaction timings from these business processes. And then as they load them up under scale, like a certain number of users, they analyze the back-end systems with monitoring tools and observability tools to put together sort of a visual for the business to say, well, under these conditions, this is what the back end's going to do. So if we believe that this number of people are going to be doing these things on our website, this is what you can expect from the back end. And so if it's not acceptable and it doesn't meet the requirements that we have for the performance characteristics, we need to make changes. We need to make tuning. Do we need to tune the database, or do we need to have more bandwidth? Do we just need more servers and have better load balancing? Those are the kind of questions that we're answering with this type of performance engineer. So those are the tools of the trade that they have. Now there are other tools. I mean, there's all kinds of now tracing and observability tools that go deep. There's profiling, and there's engineering that's done where you can actually find bottlenecks and fix issues without having to actually run a load test. But a load test is just one piece of that puzzle, or one piece, one tool in the toolbox that a performance engineer focused on the back end would use. And then we have the front end engineers. These are the folks that focused on Google Lighthouse scores, and they really talk the core web vitals talk. They get excited about looking at the waterfall graphs that you can see in the dev tools. They can understand the whole browser rendering path that happens. They know about JavaScript bundling and how, compression of images is every nuance of how the browser behaves when it's rendering that page. And they're really passionate about it. Most of the people that I've met, they really are laser focused on making that web page paint and render as fast as it possibly can. So they work in tools like Chrome Dev Tools. They use tools like Web Page Test, GTmetrix, DebugBear to monitor that end user experience. That's what they're really focused on, is what is the end user experience when they're using the browser. Now, I've spent countless hours in labs running load tests, and I've seen some really cool things that we've done where we've saw applications that were failing for less than 50 users, and it was supposed to be this enterprise app that was going to be rolled out to tens of thousands of people. And after a few days of solid hardcore tuning, we had that thing running, and we didn't need as many servers as we thought we did, and it was able to support the load and more. That's a really satisfying feeling when you see that kind of stuff. In the same respect, whenever you can show a client, hey, if you were to do these 5 things to your website to compress images and not make so many calls, or maybe your calls are just too big. If you tune some of the backend APIs, all these things that would help the web browser render faster, you will get more conversions. There are plenty of studies out there. You can check WPO stats where we can prove that if you can shave off a second off of the transaction time of a shopping cart, you can get between 7 and 10% more conversions. And I'll guarantee you, your CFO or whoever's in charge of the money at your company will know what that amount is immediately when you tell them we could get 7 to 10 more percent more conversions if we just shave off that second. Okay, they're going to be on that, right? That's a great story to tell. And some of that second might be front end tuning. It may be a little bit of back end tuning as well. And that's why I say that we need both. Both sides are completely right in what they're doing, and they have a major contribution to make to the overall performance. But I think sometimes some groups forget about the other group and their importance and their role of it. I mean, we know that what they do is important, but we just kind of forget that we need to have that, I guess, communication, or we need to bridge that gap that we have. Google Core Web Vitals are a set of user experience metrics introduced by Google to measure key aspects of your web page's performance and how it directly impacts users, how they perceive and interact with your site. And these metrics focus on three main areas. You have largest contentful paint, LCP. That measures loading performance. So a good LCP score is under 2.5 seconds from when the page starts loading. And then you have interaction to next paint, INP. That measures interactivity. That's specifically how quickly a page responds to the user input. A good INP score is 200 milliseconds or less. And then you have cumulative layout shift, or CLS. That measures visual stability, quantifying how much the layout shifts unexpectedly during the loading time. A good CLS score is one that's less than zero point 0.1. Google really began an emphasis on page experience back around 2021 when they started to formalize these core web vitals. These metrics can and do evolve. Most recently, INP replaced first input delay, or FID, as the primary metric for interactivity. So as the web changes and development changes, we will see these evolve as well. Core Web Vital uses an aggregated set of data that has a 28-day window that continues forward rolling. And so it looks at a lot of different websites, millions of websites from millions of users. It's field data, so it's real user activity. It's limited to the Chrome browser, though. It's important to note that. But these scores are based on that data. That is called the Chrome User Experience, or CRUX, C-R-U-X. So if you see that, you'll know what that means. And that is what's used to provide these scores and the metrics that tell you the pass fail. And more importantly, these Core Web Vitals are directly impacting how Google ranks your website, which means if you don't have a good score, you're probably losing money because you may not be ranking very well just because your performance is suffering. And that's important to know. So I could see another question popping up. Well, what about Google Lighthouse scores? Because you can open up DevTools in Chrome, and you can run a series of audits with this tool called Lighthouse. It's also available as a node module and a browser extension. So what it does is it runs a series of audits around performance and accessibility and even SEO, but that's not the same as field data. So what Lighthouse is really most useful for is, say you were a developer and you were working on your latest React page for your full stack web application, and you just wanted to see how well you were doing now that you've just gotten done with the first round of code or something. You could open that up in your browser and run a Lighthouse score against it, and you could see, are you already breaching SLOs? Now this is synthetic data and it's not field data, and it's in a controlled environment, but you can mimic things like a mobile device and see how bad it actually gets. Also tells you if you're missing the mark with accessibility or you've got bad SEO right out of the gate, so you can fix it right then. Something you can also do personally if you're checking a site and you're wondering why it's so slow. You could actually open it up yourself in your own browser and run it and see what it does. And you could also do that against your competitor, but I wouldn't count on that data alone. So that's different. Another question that may be popping up is, that CRUX data, if it's field data, that sounds a whole lot like RUM, real user monitoring. So is that the same thing? Well, not exactly. You could think of CRUX as an aggregated set of field data that kind of makes up their aggregated RUM report. It's not as detailed, and it's only for the Chrome browser, remember. So when you implement something like real user monitoring in a tool like DebugBear, they're actually gathering the sessions about your website, giving you real-time insights and sometimes live insights to how your website is actually doing as customers are visiting it. So think of that as like your personal CRUX report. And so you do need synthetic monitoring and you do need real user monitoring. And being able to use both, you can figure out what is going to be my score. Am I going to have a really bad score? Am I going to rank really terrible on the Google search engine? Now, if those scores were all you had to focus on, that's a whole career, and that's a lot of work in and of itself. But that's only one part of the story. You still have that whole back end that I talked about that can also affect the front end. Let's talk about that for a moment. From what I've learned, being in the field for decades as a performance engineer, is that both sides need each other. A perfect example of that is a very common thing that happens with SaaS applications. You may have a site where you have really, really good LCP and then really, really terrible LCP all in the same day. Why would that be? It probably has something to do with the cycle of load that's happening on the site. So let's say your front end looks at that and says, I know what we can do. We'll optimize the site by compressing the images as much as we possibly can. We'll implement lazy loading and we'll implement a better caching strategy. But you're still going to probably see a load wave that causes a higher time, and it may breach that 2.5-second rule that Google says is you can't do that for LCP, or you're going to get dinged for that, right? So that's when they need to be talking to the back end. And you find out that the back end is looking at it and saying, oh, I know exactly why it is. It's because under load, the API is taking a lot longer and they're waiting on the database server because the database can't keep up with it because we missed some indexes. And that's the reason why we're having this problem, because people happen to be searching more at this time. A common problem that happens is when you have poorly written database queries and the connection pooling gives out. When that happens, no amount of front-end optimization is going to fix that. That's going to take a back-end engineer and the database architects to fix. At that point, you need to be looking at the back-end monitoring tools, observability tools, but you also need to be paying attention to good data on the front end. And that's why you need a tool like DebugBear. DebugBear has it all when it comes to the front-end metrics. They've got page speed, core web vitals, all that Google Crux data. They're giving you synthetic and they're giving you real user monitoring. You can run scheduled tests against your application and run experiments to see how to make your website faster and faster than your competition and rank better, which means better SEO and more money in your pocket. If you want to see a waterfall view of your website and see exactly what's holding things up, just like you can in Google Chrome DevTools, you can do that in DebugBear and you can get very detailed, in-depth technical analysis. They have really good blog articles that will help you on your way. They also send you out emails once you've signed up that walk you through making your site better week after week. Have reasonable pricing and great documentation. It's detailed, and I was actually really impressed with it. I believe the key to getting to the roots of these problems, these performance problems, is having unified visibility. And I do believe that organizations, especially large ones, need to have cross-functional teams where these engineers sit in the same circle and they have good communication between one another. For some reason, in a lot of companies, I don't really see that. I'm wondering why. Do you know? Is your company like that? Leave a comment in the description below. Let me know what your experience has been between front end and back end. I see a future where web application performance is completely holistic and all of this information is shared. Users really don't care if it's a front end problem or a back end problem. They don't care what caused the problem. They just want to go to a site that's fast, and they will take their money to the place that gives them the best user experience, especially when the cost of switching is low. If you're not seeing the kind of detailed performance metrics that you think you should be seeing, like real user monitoring for your web application, check out DebugBear today and see what they can do to help you make the website as performant as it can possibly be. Until we see each other in the next video, this is Scott Moore saying bye-bye.